Yeah, good afternoon. Um, we were discussing about shallow foundations in our last class. Okay, so this will be the probably last class for this unit. Okay, that is shallow foundations. Okay, all of you can hear my voice, right? So in the last class we have solved some problems. Okay, so today also I will continue with some more problems, and this will be the, the last class for the shallow foundations. Okay, so then from the next class onwards I will start a new unit, that is pile foundations. Okay, so that is deep foundations. Hmm? So all of you can see my whiteboard. Yes, please respond.
Yes, sir.
Okay, so look at this problem. What they are telling: uh, calculate the ultimate bearing capacity of a 2-meter wide square footing resting on the ground surface. Okay, so they are telling, see, footing resting on ground surface uh, of sand deposit with the following properties. What are those properties? Unit weight they given, angle of internal friction they given. Also calculate the ultimate bearing capacity of the same footing when footing is placed at a depth of 1 meter. Okay, so if it is placed in at a depth of 1 meter, and if the same footing is placed at the ground surface, so they are asking you to calculate the bearing capacity. Okay, so then if the ground surface, first case one, you calculate without any depth. Okay, so just by putting the foundations at the ground surface you calculate the bearing capacity. Then in the second case, you put your foundation at 1 meter depth and then calculate the bearing capacity. Okay, and then look how much the bearing capacity it is changing because of the depth of the foundation. Okay, so first let me draw the figure. So please take a pen and paper and also calculator, so you should solve along with me. Okay, so this is my ground. Hmm? So this is the ground. Okay, so this is ground level. Wait a minute, I think I have some problem with this highlighter. I will disable this. Okay, so this is my ground level and this is my footing. Okay, so what is the size of footing? Calculate the ultimate bearing capacity of a 2-meter wide square footing. Okay, so this is 2 meter by 2 meter wide square footing. So this is my ground level. Okay, so this is my case one. Hmm? So case one is footing resting on ground surface. Okay, so that is my case one, ground surface. Okay, uh, and my case two will be the same figure I will draw here. But instead of the ground level at this point, now your ground level is at a 1 meter depth. Oh, sorry, your foundation is at 1 meter depth. Okay, so here is my ground level. Okay, so this is my ground level, and then this is my depth of the footing. Okay, so these are the two cases you have to consider. This is my case 2. So case 2 is what? Footing resting at 1 meter depth from where? From ground level. Okay, so first these are the two cases, and what are the soil properties they given? They given gamma is equal to 18 kilonewton per meter cube. Okay, and angle of internal friction they given phi is equal to 38 degree. Also calculate the ultimate bearing capacity of the same footing when a footing is placed at a 1 meter depth, and take NQ N gamma. Okay, so NQ, how much for this phi value? NC they not given because this soil doesn't have any cohesion. Okay, so it's a pure cohesion less soil. So anyway, that NC will become 0. And C, once the C becomes 0 means NC will become 0. That's why they are not given a NC value. Okay, so they given only NQ value they given. How much they given NQ? 41.4. And N gamma also they given. How much they given N gamma? 42.2. 42.2. Adopt Terzaghi's equation they are asking, and also calculate the percentage increase in bearing capacity with the increase in depth from surface to 1 meter. Okay, so they are asking you to calculate the how much percentage has been increased if you place the foundation on the ground level, and if you place the foundation 1 meter below the ground. Okay, so let's first calculate the ultimate bearing capacity with for the case 1. Okay, so QU is equal to, what is the formula? This is square footing now, so 1.3 CNC plus QNQ plus 0.4 gamma B N gamma. Okay, so anyway, this term is going to be 0. Why it is 0? Because C is 0 here. C is 0. So that's why this term is going to be 0. And you see Q and Q, this term also will be 0. Why? Why this term is 0? Can anybody tell me? Why this Q and Q term is 0? Because there is no depth. Because this second term, whatever this second term is there, no? This second term is contributed by whom? The second term is contributed by the soil present above this footing. Okay, so whatever this soil is there, no? Whatever soil present here, above this foundation. So from here, whatever soil is there, this thing is going to contribute. But there is no depth of foundation here. Since there is no depth, so that's why this Q and Q term is also going to be 0. So only you left with 0.4 gamma B N gamma. Okay, so you calculate 0.4 into gamma is 18 into breadth is 2 meter into N gamma is how much? N gamma is 42.4. How much? Q ultimate. How much you are getting? How much?
627.610.
607 I am getting.
618.6. 10.56.
610 now.
610, sir.
Okay. Around 610 I will write. Okay, so 610 something, some kilonewton per meter square. So 0.4 into gamma into So into 42.2. See, this is 42.2. This one 42.2. 42 point. This is 42.2. Okay. So in that case, you will get 607, I think. Okay. So
Yes, sir.
607.7 kilonewton per meter square, right? So this is my case 1. What is the case 2? Case 2 is now, sorry, case 2 is now the soil. Now you have a depth of foundation. How much depth of foundation they're asking? Depth of, now same footing when the footing is placed at a depth of 1 meter. Okay, so depth of 1 meter. So depth of footing is 1 meter. Okay, so now you calculate. So Q ultimate equal to 1.3 CNC plus QNQ plus 0.4 gamma B N gamma. Okay, so anyway, this term is going to be 0 because C is 0 here. Now, what is QNQ? QNQ is nothing but the contribution by the soil present above the footing. Okay, so above the footing, how much? 1 meter depth is there. So 1 into its unit weight is 18. 1 into 18 is my Q value into NQ. What is NQ? NQ is 41.4. So 41.4 plus 0.418 into B is 2 meter and N gamma is 42.2. 42.2. How much you are getting?
1352.8.
Okay, 1352.8. 1352.8 kilonewton per meter square. See, this is my answer for the case number 2. Okay, so now they're asking you how much percentage it has been increased. Okay, so from the from case 1 to case 2. This was the answer of case 1. No. Yeah. So from 607, it has been increased to 1352. So calculate how much percentage it has increased.
55%.
Around 55% it has increased. Okay. So the percentage increased. So percentage increase in bearing capacity. Okay, so I will write short term. BC is nothing but bearing capacity. Percentage increase in bearing capacity is equal to so you 1352.8 minus how much earlier? 607. No, 607.7 divided by 1352.8 multiplied by 100. So you are getting around 55%, right? Very good. So 55% it is increased. You see, just by giving 1 meter depth to your foundation, you are almost doubling your bearing capacity. Okay, as you increase the depth, obviously bearing capacity will increase. Okay, so let's go to next problem. Yeah, this problem you see, 7th one. What it is telling, you see. what it is again, determine the safe bearing capacity of a square footing with the 2.1 meter, determine the safe bearing capacity of a square footing. Again, it is a square footing. Okay, it is a square footing with the 2.1 meter depth, placed at a depth of 1.5 meter in a soil with the moist unit weight 17 kilonewton, cohesion, angular of internal friction they given, NC, NQ, and N gamma they given. What is the change in bearing capacity if the water table rises to 0.5 meter above the base of the footing? Assume factor of safety as 3. Okay. So let me first draw the figure. Okay, so this is the ground level. Okay, and what is the size of footing? It's a square footing, 2.1 by 2.1. Okay, so 2.1 meter by 2.1 meter. Okay, so what is the depth of foundation? How much depth? Placed at a depth of 1.5 meter. It is 1.5 meter. In a soil with a moist unit weight. Moist unit weight is nothing but your bulk unit weight. Both are same, both moist or bulk. So 17 kilonewton per meter cube. And C they given. C how much they given? C they given 15 kilonewton per meter square. And phi value also they given 20 degree. And for this 20 degree, they given NC. NC as how much? 11.8. And NQ, how much? 3.9. And N gamma? N gamma 1.7. Okay. So what is the change in bearing capacity if the water table rises to 0.5 meter above the base of the footing? Again, here also there are two cases. So one case without considering any water table, and second case is if the water table is rises to 0.5 meter above the base of the footing. That means so let me draw here. So this is the water table. Okay, so how much it is rising from the footing level? How much it is rising? 0.5 meter. So first case 1 I will write. Okay, so case 1, that is without any water table. Okay, so Q ultimate is equal to CNC. It's a square footing, no? So 1.3 CNC. Okay, so Q ultimate equal to 1.3 CNC plus QNQ plus 0.4 gamma BN gamma. So 1.3 into what is the cohesion they given? 15. 15 into what is NC they given? 11.8. Okay, now second term. What is the second term? QNQ. QNQ is nothing but the depth times your unit weight. So depth is 1.5. 1.5 into unit weight, how much? 17. 17 into NQ is how much? 3.9. Plus, what is your third term? 0.4 gamma B. B is 2.1 into n gamma. N gamma is 1.7. So this is my third term. Okay, now calculate how much you are getting. Q ultimate equal to
355.25.
350. I think 354 I am getting. 354 kilonewton.
355.25.
Yeah, 354 kilonewton per meter square. Okay. So this is my case 1. Okay, now for the case 2 we calculate. So case number 2. What is the case number 2? If the water table rises by how much depth? 0.5 meter from the footing level. Okay, calculate. So Q U equal to, again same 1.3 CNC plus QNQ plus 0.5, sorry, 0.4 gamma B N gamma. Okay, so now see how much depth it is left here. See, now if 0.5 by 0.5 meter depth, if water table is rising above the footing level, then what is happening here? This soil is what? This soil is in a dry condition. So this soil is under submerged condition. This much soil is under submerged condition. This is under submergence. Okay. Okay. So let me calculate the first term. First term is 1.3 into your cohesion is how much? 15. Into your NC is how much? 11.8. Okay. Okay. Now you concentrate here. How I will calculate Q value. Okay. So this soil is in a dry condition. I should take the dry unit weight. And this soil is under this one under submerged condition. So I have to take buoyancy unit weight or submerged unit weight. So since they are not given the water table, since they are not given the water content of this soil, I cannot find out the dry density. See here, this soil I am considering it as a dry, but they are not given the water content. How much water content is there? I know the bulk density. Okay, so from bulk density, I can calculate dry density, right? So gamma D is equal to gamma bulk divided by 1 plus W, provided the water content is given here, but they're not given the water content. So what I will do, I will consider your bulk density as a dry density. Okay, so your bulk density and dry density, that means your water content is very, very small, almost negligible in this soil. Then only your bulk density will become dry density. So 17 into, see, this is 0.5 means this is how much depth? This is 1 meter depth, no? 17 into 1, no? So 17 into 1, no? Plus, let me erase this. Square bracket I will put here, okay? 17 into 1 plus what? This 0.5 meter into the submerged unit weight of this soil. Okay, so this much soil is under submerged condition and this much soil is under dry condition. Okay, so how you will calculate the submerged density? That is nothing but 17 minus your unit weight of water. Okay, so I will take unit weight of water as 10. Okay, even you can take 9.81 also, no problem. Even you can take 9.81 or 10 into how much depth it is? 0.5 meter. Okay, so this entire term is what? This entire term is Q value. This one. This entire term is Q value. Into your NQ value. NQ is how much? 3.9. Plus What is the fourth term? Fourth term is 0.4 into 0.4 into gamma. Anyway, gamma, now I have to take the submerged density, because the third term, who is contributing the third term? This third term is contributed by the soil present below the footing. Okay, so soils present below the footing is under submerged condition. So I have to take the submerged unit weight. 0.4 into 17 minus 10 into your breadth of footing is 2.1 into your n gamma is 1.7. Calculate how much you are getting. How much? 320, yeah? Yeah, very good. So Q ultimate. So Q ultimate, you are getting around 320. 320, am I right? 320, are you getting 320? 320 kilo Newton per meter square. Okay, so now you compare here. If the water table is rising by 0.5 meter, how much it is reducing? You see, almost from 354 to it is coming back to around 320. How much percentage it has been reduced? How much percentage it is reduced? Percentage reduction in the bearing capacity due to rise in water table by 0.5 meter. So percentage.
472.
This is 472. Huh? What 472 you are telling?
QU of case 2.
No, it's not 470. 320 only it is. 320. Anybody is getting 320? Is it right? If anybody is getting 320 for the case 2, please let me know. Huh? Oh, it's 320. Please calculate. Who somebody is telling 420, but it's not 420. No, please calculate once again. You may be doing some mistake. Yeah, it should come 320 only. Okay, so how much percentage it is decreasing? Tell me. From case 1 to case 2. Percentage.
10.
Yeah, almost 10%. Percentage reduction in bearing capacity of soil by rising water table. Okay, so almost earlier I got 354, no? 354 minus 320 divided by 354 into 100. But almost 9.6% reduction. Okay. Okay. So next problem you see this problem. What they're telling in this problem? Check. Stiff footing, 2 meter wide, carries a load intensity of how much? 4,000 kilonewton per meter square at a depth of 1.2 meter in sand. The saturated unit weight they given, the unit weight above the water table. This is your bulk density or dry density, you can call the water table, the unit weight which is above the water table. If the water table below the unit weight below the water table, if they are giving, means that is a saturated unit weight. The shear strength parameters are C is equal to 0. Okay, so there is no C. That means this soil is pure sand, and phi is equal to 35 degree. Determine the factor of safety with respect to shear failure for the following cases of location of the water table. Okay, so there are how many cases? Three cases are there. In the first case, the water table is at 4 meter below the ground level, and second case, water table is 1.2 meter below the ground level, and third case is water table at 2.5 meter below the ground level. Okay. So for the phi equal to 35 degree, they given NQ and N gamma. They're not given NC because of course C is 0. So that NC term is going to be 0. Okay, so that first term is going to be 0. That's why they're not given NC value. Okay, so first let me draw the figure. Okay. Okay. So it's a square footing, again 2 meter by 2 meter. Carries a load intensity. How much? They given this load intensity. They given how much load intensity? That is small q. Small q, how much? 400 kilonewton per meter square. At a depth of 1.2 meter from the ground level. Okay, so the depth of foundation is how much? 1.2 meter. So the saturated unit weight of sand is 19.5. Okay, so gamma sat. So gamma saturated is how much? 19.5 kilonewton per meter square, and unit weight above water table. Okay, so that means that will be your bulk density, or it may be dry density. If they given the water table water content, then I can find out the dry density. But for timing, I will assume it as a bulk density, which is 16.8 kilonewton per meter cube. Okay, so sorry, this is cubic meter. Okay, the shear strength parameters. Okay, so C is equal to 0, so and phi is equal to 35 degree. Okay, so for this phi value, what is NC value? NC value they given 41.4, and N gamma value how much they given? And sorry, not NC. This is NQ. NQ and N gamma. N gamma how much they given? 42.4. 42.4. Okay, so that means the factor of safety with respect to the shear failure. They are asking you to find out the factor of safety for the following cases. What are the first case? First case is this one. The water table is at 4 meter below the ground level. Okay, so that means I will get some space here so that I can solve the problem. Okay. Okay, so first case is the water table at 4 meter depth. Okay, so what is the depth of influence? See, up to 2 meter. So the depth of influence is, suppose this is 2 meter. So up to here, this is depth of influence. Depth of influence of water table. So first, in the first case, the water table is 4 meter below the ground level. That is 2 plus 3.2. Okay, so 4 meter is obviously greater than 3.2 meter, right? So that means there is no effect of the water table. Okay, So the water table they are giving in the first case is somewhere here. Okay. So this is my water table. Okay, so this is my case 1. So what is the depth of water table? How much? Okay. So 4 meter depth. Now first case is at 4 meter depth. Okay, so this is my depth of water table. Okay, so this is dw. So dw is equal to 4 meter. Okay, so in the first case there is no effect of the water table. Okay, so as it is you can calculate. Okay, so first case number 1 I will write. Case 1, that is what? Depth of water table is at 4 meter from ground level. Okay, since your dw is greater than what? Depth of footing plus your width of footing. So no effect of water table at this depth. Okay, so straight away you can calculate Q ultimate equal to CNC plus QNQ plus 0.5. This is square footing, no? Yeah. So 0.4 here, 1.3. Sorry?
0.5, sir.
No, 0.5 is for strip footing. It is a square footing, no? 2 by 2 meter, it is a square footing. That's why it is a 0.4. Huh? So if it is a strip footing, then it is a 0.5. Suppose if it is a circular footing, then it is 0.3. Okay, 0.4 into gamma B n gamma. Okay, so C, this term is going to 0. First term is going to be 0 because C value, its cohesion value is 0 here. Huh? So what is the second term here? Q times NQ. Q is how much? Depth of foundation is 1.2 meter. 1.2 into your bulk density I have to consider here, not saturated density. So when I should consider saturated density, if the water is if the unit weight of the soil, given soil, is under the water table, then that will be my saturated unit weight. Okay, since there is no water table here, so I have to consider the bulk density 16.8. Don't get confused between which one to use. Okay, so this gamma is there, no? Always you should use gamma saturated unit weight if you are dealing with the soil which is present below the water table. Okay, if the soil present above the water table, either it may be a bulk density or it may be a dry density. Are you getting it? Should I write here? Suppose this is my groundwater table. So this is my groundwater table. Whatever soil present below the groundwater table will be saturated soil. Saturated soil. What do you mean by saturated soil? If you recall from your fifth semester, that is three-phase diagram. The three-phase diagram. What we were telling? We have a solid phase, and then we have a liquid phase, and then we have a air phase. So saturated soil means there is no air. All the air is occupied by fully water. Okay, that is my saturated stage. Okay, so below the water table, we will be having only 2 stages. Okay, so solid phase and the liquid stage. Only 2 phase will be there. So above the water table, we have either it may be a dry. If the all the white space is occupied by water, obviously it will be saturated soil. Okay, suppose I will dry here above water table. So above water table condition, we have 2 cases. One, may be partially saturated. Partially saturated means we have solid phase, and we have a liquid phase, and we have a air phase. Okay, or we can have a solid phase, and then only air. There is no liquid. So solid and air is there. Then you should then this case will be your unit weight of dry unit weight. If all the three are there, then this will be your bulk unit weight. And if this is the case, then it will be your saturated unit weight. So since here there is no water table, I have to consider whatever densities they given, I have to consider as a bulk density. So that is a 16.8 kilonewton per meter cube is that I should consider it as a bulk or dry density. Okay. So 16 point how much? So 16.8 into what is the depth of foundation? What is the depth here? 1.2 meter. So 1.2 into what is the NQ value they given? NQ value is 41.4. 41.4. Okay, so this is my second term plus what is the third term? 0.4 into gamma is 16.8 into width of foundation is 2 meter into n gamma is how much? N gamma is 42.4. Calculate how much you are getting. Q ultimate. So Q ultimate you should get 1546.94 kilonewton per meter square. So this is my case 1 ultimate load, but they are not asking you to stop it here. Okay, so they are asking you to what they are asking here, factor of safety they are asking. Okay, so then what is factor of safety? It is nothing but your so then you have to calculate Q allowable. Okay, so this Q allowable is nothing but your Q ultimate divided by factor of safety. Okay, so your Q allowable is nothing but your Q ultimate divided by factor of safety. Okay, so they are asking you to calculate the factor of safety. So factor of safety is equal to the Q ultimate divided by Q allowable. So what is the ultimate load here? 1546.94 divided by Q allowable. What is the Q allowable? They given in the problem. How much? 400 kilonewton per meter square. So 400. So calculate how much factor of safety you are getting.
3.86.
3.87%. So this is my case number 1. So this much factor of safety you are getting in the case 1. Now coming to the case 2. Case number 2. What is the case 2 here? So water table is at 1.2 meter below the ground level. So let us draw. This is 1.2. No, so 1.2 meter means exactly here. So dW is equal to 1.2 meter. Okay, so this is my case 2. Case 2. Okay. So this was my case 1. Case 1. Okay. So now the water table is exactly at the foundation level. That means what happened? Now this much soil. Okay, so please see my highlighter here. Okay, so from here to here, the soil is under dry condition. From the foundation level, the soil is under saturated condition, because now the new position of the your groundwater table is somewhere here. This is my case number 2 groundwater table. So this much soil is under dry case and this much soil is under a saturated case. Okay, so let me get some space here. Okay, so write down the formula. Q ultimate is equal to CNC QNQ, again 1.3 CNC. Anyway, this term is going to be 0 here, plus 0.4 gamma B N gamma. Okay. Okay, someone was telling oh my god, see, this is a strip footing. See, this is strip footing. Somebody was asking, no, in the just some time back, he was telling this is 0.5. Okay, so C is correct, because the given foundation is strip footing. I thought it is a square footing. Sorry. So in that case, this is strip footing. I did not read the properly this problem. Okay, so this is the strip footing, not square footing. Okay, so strip footing. So 2 meter width is this. What is the width of strip footing? 2 meter width. Okay, so in that case, what are the changes are going to happen here? So instead of this 0.4, now it is 0.5. This is wrong. No, you should not take 0.4 here. No, you should take 0.5. So, and then anyway, this term is going to 0. So even if you write 1.3 or not, it doesn't matter. Okay, so this is also wrong. So 1.3 should not come here. Okay, so it's only CNC. Okay, so now anyway, any changes are going to happen for this answer? Calculate once again.
No, sir.
No. Yeah. So I think very minute change, and whatever answer I written, that I think I calculated with 0.5 only. Yeah, this is correct. So this is also correct. Only mistake is here, instead of 0.4, I should write 0.5. That is the only mistake here. But answer is same only. Okay. So here also I should write 0.5. See, only one student has noticed whatever mistake I have done. You should be read it properly. Problem. Okay, so it's a strip footing, not a square footing. Since it is a strip, your shape factors is going to change here. Okay, so if you have a strip footing, shape factor here 0.5, or if you have a square footing, then shape factor is 0.4. If you have a circular footing, then it's 0.3. Okay, yeah, let's continue here. So this term QNQ, Q is how much? What is the unit weight here? Okay, so anyway, this soil is in a dry condition, so I have to take bulk unit weight or dry unit weight. 16.8 into 1.2. Okay, so 16.8 into 1.2 into NQ. What is NQ value? How much? What is the NQ value? NQ value is 41.4. 41.4 plus 0.5 into gamma. Okay, now you see the third term. Who is contributing third term? The third term is contributed by the soil present below the footing. Okay, so whatever soil present from this level to this level is contributing for the third term. Okay, so since my soil in the third term is a saturated soil. Okay, so I have to consider its submerged unit weight. Okay, so what is the submerged unit weight? Submerged unit weight is nothing but your saturated unit weight minus unit weight of water. Okay, so saturated unit weight is 19.5. So 19.5 minus, I will take 10 as the unit weight of water. Okay, so this is my unit weight of water. Even you can take 9.81 also. no problem. Okay, so 9.81 also is fine. Either 9.81 or 10. So I will take a 10 because for the just for the sake of computation purpose. So gamma into what is the width of foundation? 2 meter into n gamma. What is the n gamma? 42.4. 42.4. Okay, so calculate how much you are getting. Q ultimate.
1237.4.
1237.4. Very good. 1237.42 kilonewton per meter square. Okay, so what is the Q allowable? The Q allowable is nothing but Q ultimate divided by factor of safety. So then now, what is my factor of safety? The factor of safety is equal to, let me write properly. So Q ultimate divided by Q allowable. So Q ultimate is 1237.42 divided by allowable is 400, right? Yeah. How much you are getting? 3.1. 3.09. 3.1 I will take. Okay, so 3.1%. Okay, so that is my factor of safety, not percent. Okay, so it's just 3.1. That is my factor of safety. So this is my case number 2. Okay. So what is this case number 3? So let me get some more space here. What is the case number 3? You see, water table is 2.5 meter below the ground level. So how much? The water table is 2.5 meter below the ground level. So that means this is 2 somewhere here. Okay, so how much? What is the depth? Depth of water table? dW is equal to 2.5 meter. 2.5 meter. Okay, so this is my case 3. Case 3. So now what will happen? So this much soil, whatever soil above these pink lines, all are in a dry case, and the soil present below this pink line are under saturated condition. Okay, so now calculate Q ultimate for third case. Case number 3. Case number 3, that is the water table is at a depth of how much? 2.5 meter, no? Yeah, 2.5 meter below ground level. Okay, so first let me write the formula here. Q ultimate equal to CNC plus QNQ plus 0.5 gamma BN gamma. Okay, so this term is 0. Now QNQ calculate. So QNQ is in that region. Okay, so the second term region is dry soil. Okay, so what is the depth here? Depth is 1.2 meter is the depth of foundation. 1.2 into your dry density or bulk density, that is 16.8. How much Q is dry unit weight? How much I told? Dry unit was 16.8, no? 16.8 into what is the depth of that footing? That is 1.2. 1.2 into NQ. Okay, so NQ value you see how much the NQ value? NQ 41.4. So 41.4 plus 0.5 into, you see this gamma is now a tricky one because in this this third term, whoever contributing this third term, no, part of that soil is on dry soil, and the part of that soil is under a saturated condition. You see, now I will mark here. You see, just concentrate here. Okay, so this much soil is what under dry case. This much soil is under dry, and this soil is under submerged case. This soil is under submerged case. So that's why I have to take weighted unit weight. Weighted unit weight I should take. So that's why I will represent that gamma as a gamma double. I will represent this as weighted unit weight. Okay, so I will represent it with gamma double dash into, anyway, breadth is 2 meter, and your n gamma is how much? N gamma is 42.4. So 42.4. Now my job is to find out this gamma double dash. Let me calculate that gamma double dash. So gamma double dash is, can you recall that third case formula? Gamma double dash is equal to gamma saturated minus gamma W into 1 minus your depth of water table minus your depth of footing divided by the width of footing. So that you calculate that one. So saturated unit weight, how much they given? How much they given saturated unit weight? 19.5. Very good. So 19.5 minus I will take unit weight of water as 10. 1 minus dW minus d. What is the depth of water table they given? Third case depth of water table 2.5 meter. 2.5 minus depth of footing 1.2, no? Depth of footing is 1.2, yes. And what is the width of footing? 2 meters. How much you are getting? This gamma double dash. How much?
3.32.
Huh? How much?
3.32.
3.32. So,
3.32.
okay. Please do once again. That much less you won't get submersible.
16.
16, huh? Yeah. 16 kilonewton per meter cube. Everybody is getting this much? 16 kilonewton per meter cube? Huh? Now you put this one here. In this equation you put. Then calculate Q ultimate. So Q ultimate, how much you are getting? Tell me. See, everything you know now. Only this gamma double dash now I calculated from this weighted unit weight.
1513.02.
Sorry, 15?
1513.02.
1513, yeah. 102 kilonewton per meter square. So this is my Q ultimate.
Sir, gamma double dash.
Gamma
To
double
get
dash.
it, 16, we need to make 1 plus.
What? Sorry, tell me.
Sir, if you take 1 minus dw minus d by b, no sir, we'll get 3 point. If we take 1 plus, then answer will be 16.
1 plus. Let me once again check the formula here. I think 1 minus or 1 plus. It's 1 minus now. 1 minus dw minus d by b. It's 1 minus only, no? See the formula. Anyway, let me calculate once again. Okay, so this 2.5 minus 1.2 divided by 2. Okay, so this 1 minus this answer multiplied by 10, 3.5. Okay, so 19.5 minus answer. I'm getting 16. Correct, it is 16. I'm getting here. Maybe you are not multiplying this 10. You check it once again. You do calculation once again. I'm getting 10. See, I'm getting correct answer. 16 kilonewton per meter cube. I'm getting.
Yes, sir.
Huh? Is it okay?
Yes, sir.
Okay. So Q ultimate I got. Now Q allowable I should calculate. Okay. So the Q allowable is equal to Q ultimate divided by factor of safety. Okay. So I need a factor of safety, right? So factor of safety is equal to your Q ultimate divided by Q allowable. So this is allowable. Let me correct it. Q A allowable. Okay. So 1513.02 divided by your 400. That is allowable load. Sorry, allowable load bearing capacity. So how much factor of safety you are getting? How much?
3.7.
3.7. Very good. So 3.7 is your factor of safety. So now you compare all the factor of safety where you got highest factor of safety. The 3.87 was my factor of safety in the case number 1. Okay, so that means the water table was not at all in the picture, right? So 3.87 I got. Once the water table is raised up to in the case 2, where is my case 2? Case 2. This was my case 2 with green ink. Where it come up to your footing level, then my factor of safety is reduced to how much? 3.1. Okay, so next in the third case, you see again it is increased because the water table is went down. No, see, the water table was here pink color. So from how much depth it was? 2.5 meter below the ground level. At the same 2.5 meter below the ground level means what is the disk depth from the footing level? So 1.2, sorry, 2.5 minus 1.2. Okay, so that is the depth of water table from your footing level. Okay. Any doubt here? See, if you followed this problem, then you can solve any problem on the this chapter. So this case includes all the possible position of your water table. So except one more case, it should be there. Like if the water table is at the ground level, exactly at the ground level. Okay, so that is like a worst case. You can take it as a homework. So what you do? You put your water table at exactly at the ground level. Should I calculate that also? You want me to calculate, or you are able to do that? Even though they are not asked in the problem, but you take it as an assignment. Okay, so you put the water table at the ground level and then you calculate the factor of safety, how much it is reducing, you see. So almost 50% it should reduce from the case number 1. So if you have time, I can solve that case also if you want. Tell me. Do you have time? How many are there still? 30 people are present. What should I do? You want me to solve or you will solve it? Aishwarya, what should I do? Take it as a homework. It's very simple. Okay, so what will happen now? Entire soil is under submerged condition. If the water table comes at the ground level, what will happen? Even your second term and third term, all the 3 terms, I should take submerged intubator. Okay, so anyway, quickly I will solve that case also. Okay, so I will put the water table at this level. So this is my case number 4. This is case number 4. So case 4. If the water table is at ground level, what will happen? You see, Q net, so Q ultimate equal to CNC QNQ 0.5 gamma B M gamma. So this term is 0. So Q term you calculate, Q term. Calculate the Q term. So Q term, your depth of foundation. What is the depth of foundation? 1.2 meter into the submerged unit weight. Okay, so submerged unit weight is nothing but your saturated unit weight minus unit weight of water. Okay. So Q is nothing but your submerged unit weight was how much? Submerged unit weight is 19.5 minus 19.5 minus 10. 10 is the unit weight of water I will take. Okay, your 9.8 is also you can take. Into the depth of foundation is 1.2 meter into NQ value. What is the NQ value? NQ value is 41.4. 1.4 plus. Okay, second term you take 0.5 into, anyway, soil is submerged condition. No, all the soil. Second term soil is also submerged condition, and third term soil is also submerged condition. Okay, so 19.5 minus 10 into width of foundation is 2 meter into N gamma. N gamma is how much? N gamma is 42.4. So 42.4. Calculate how much you are getting.
874.
874, huh?
Yes.
Please do carefully, because I have not calculated this term. I have not calculated in my earlier. I have not calculated. Okay, so I am totally believing on your answers. So 874 is correct. Please cross check somebody else whether 874 are you getting.
Yes, sir, it's correct.
Okay, so kilonewton per meter square. So now, what is Q allowable is equal to Q ultimate divided by factor of safety. So I need factor of safety is equal to Q ultimate divided by Q allowable. So Q ultimate is 874. 874 divided by Q allowable is 400. How much are you getting?
2.18.
2.18. Okay, so maybe 2.2 I will take it. Okay, so 2.2 is my factor of safety. You see how much it is reduced from the this was my case 1. Sorry, this is my case 4. So in the case 4, that is the water table exactly at the ground level, I'm getting factor of safety of 2.2. But if there is no water table at all, then what was the factor of safety I was getting? That is my case number 1, that is 3.87. So let me put here one more. That is fourth case. Water table is at the ground level. Okay. So anyway, this case extra we have solved. Okay. So this was not asked in the exam. Just for the practice purpose, we'll put this one. Yeah. So any doubt regarding this problem? So this is very important problem. This is almost all the cases it involves. If you understood this problem, then there should not be any problem to solve any problem in this chapter. Shall I go for next one?
Yes, sir.
Yeah. Yeah. What was the number this one we solved? This was the 8th problem. Yeah. So let me put this as 9. No, it is. What they are telling you, see. Now, see, circular footing is coming here in the 9th problem. The circular footing rests on pure clay, they are telling. Okay, so on the pure clay, that means only C will be there. Okay, so only C will be there. There will not be any phi. Phi will be 0 here. Your angle of internal friction will be 0 because it's a pure clay. With the undrained compressive strength, QU is nothing but undrained compressive strength. QU is equal to 270 kilonewton per meter square at a depth of 1.8 meter. Determine the diameter of the footing. If it has to transmit a load of 720 kilonewton, assume the bulk unit weight 18 kilonewton per meter cube, and the factor of safety is 3. Okay, so let me draw the first figure. This is my circular footing. I will try to draw a circular footing. But in the sectional view, it won't look like circular. But only in the plan view only you will see the circular. Okay, so anyway, I will draw the sectional view only. I will draw sectional view. In the sectional view, it will look as your normal square footing only. But only if you see in the plan view, you will see that circle. So it's a circular footing. Circular footing. Okay. Of diameter, how much? Circular footing. Okay, diameter they are asking. Okay, so that is question mark. With the QU they given. Okay, so QU is nothing but your unconfined compressive strength. It's called as unconfined compressive strength. Okay, UCS we will call. Okay, so UCS. So this QU is there. From this QU, I can calculate the cohesion. Okay, so this undrained cohesion I can calculate. Cu is nothing but your half of your QU. So 270 kilonewton per meter square divided by 2. How much? 135
135.
kilonewton per meter square. Very good. Okay. Determine the diameter of the footing if it has to transmit a 700 kilonewton. Okay, so what is the load it is transmitting? It is my capital Q. 700 kilonewton. Assume the bulk unit weight of soil as 18 kilonewton per meter cube. Okay, so what is the gamma? 18 kilonewton per meter cube. And the factor of safety they are asking you to take how much? 3. Now, what is the formula for the ultimate bearing capacity for the circular footing? 1.3 CNC QNQ plus 0.3 gamma B N gamma. So, see, for phi is equal to 0, in this case you should remember, for phi is equal to 0, NC is equal to around 5.7 and NQ is equal to 1 and N gamma is equal to 0. Okay, so these details they will not be given. Okay, because for phi equal to 0 you should remember. Okay, so this is the bare minimum you should remember. Okay, so for, at least for phi equal to 0, so NC is 5.7, NQ is 1, N gamma is 0 from the Terzaghi's bearing capacity theory. Okay, so that table, if you remember, what is this Terzaghi's bearing capacity? You see, for phi equal to 0, NC is 5.7, NQ is 1, N gamma is 0, 0. Okay, so you have to remember this case because sometimes they expect you to remember for phi equal to 0. Okay, so this case you should remember. These values will not be given in the problem. 5.7, 1 and 0, and also it is easy to remember. Anyway, this will be 1 and 0 and NC will be 5.7. Okay, so no need to remember for other phi value. At least for phi value of 0 you should remember. Because for other phi value they will be given the problem in the problem itself they will give. Okay, come back to this problem now. So NC is how much? 5.7. Sorry, first 1.3 into cohesion. How much I calculated? 135. 135 into NC is 5.7. Okay, so this is my first term. Plus, what is the second term? This is my ground level. And what is the depth they given? Depth of footing. 1.8 meter, no? Yes. D is equal to 1.8. So 1.8 into the unit weight they given is 18. Okay, so 18 into NQ is 1. Plus the third term anyway is 0 because N gamma is 0 here. Third term is 0. Calculate Q ultimate. How much?
1032.
1 minute, I will get some space here. How much? 1032. Very good. 1032. Point I think 75.
75.
Yeah, kilonewton per meter square. Okay, so what is the Q allowable? Is equal to Q allowable is equal to your Q ultimate divided by the factor of safety. Okay, so 1032.75. So factor of safety, how much they are telling? They are asking you to take 3. Okay, so what is the answer? So I think 344.25 kilonewton per meter square. Okay, they are asking you to find out the diameter. Okay, diameter of the footing. So how you will calculate? So this is the stress. Okay, so this Q allowable into area. If you multiply by that with the help of area, then what I will get? I will get the load applied on the column. Okay, so Q allowable is how much? 344.25. that is my Q allowable into area of circular footing pi by 4 into d square is my area of the circular footing is equal to Q. Anyway, they given how much load there are 700 kilonewton they are telling. Okay, so that 700 kilonewton. Okay, now only unknown is d square. What is the d here? How much d you are getting? Check. What is the diameter of the? What is the diameter of the footing? 1.63. Yeah? Yes, 1.63 meter. Okay. So that is your footing diameter. Okay, so this to register 700 kilonewton load. What should be your diameter of footing? 1.63 meter. Okay. Any doubt here? So this is asked in 2015. Very small problem for 6 months. But somewhat little bit trickier. Okay, so you may not understand what is QU value. Okay, so QU is nothing but unconfined compressive strength. Okay, so you would have studied in your 5th semester. Okay, so that's why I always some 5th semester concepts are very important. Okay, so whatever the chapters we are now in this subject, it is called as applied soil mechanics. Okay, so in the 5th semester it was called as basic soil mechanics. So whatever basic soil mechanics concepts you have studied, so those concepts will be applied in the actual field condition. Okay, that's why it's a continuation of that 5th semesters. So from that chapter it is coming. Okay, your unconfined compressive strength. It is nothing but your from this unconfined compressive strength I can calculate the undrained cohesion here. Okay, so next there are some more problems I put here. Okay, so see these problems are exactly same. If you would have followed all these problems, then there should not be any issue to solve these problems. Okay, so these problems you solve on your own. So these are just based on whatever concepts we have discussed in solving these all the 9 problems. Okay, so if you have understood that all these concepts taught in these 9 problems, then there should not be any problem to solve this 10, 11, and 12. Just exactly same like your previous problems. Just some numerics are changing here. There is no special or a new concept involved in these problems. So you take them as a homework, you solve on your own. And if you face any problem, then let me, you can ask in tomorrow's class. Then I will try to solve the problems. So this is your end of the shallow foundations. If you have any doubts, if you want to ask anything about regarding the shallow foundations, now you are free to do so. So because from the next class onwards, I will start a new chapter. Okay, so that is your D foundations. It is the 5th unit. Yeah. Any doubts regarding shallow foundations? Please feel free. Feel free to ask any doubts. Okay, so if you are shy enough to ask here, you can message me on my, anyway. All of you have my phone number, so do message me if you have any doubts regarding the whatever concept till now we discussed. So what I will do now, I will stop the recording and also